Good morning. Suppose we have a circuit, following circuit, and we are asked to calculate the current flowing here in this resistor and the current flowing in this resistor. Well, let's draw the circuit a different way, this way, and I'm going to use the current divider rule to calculate the currents. So to calculate the main current, we need the equivalent resistance between A and E. Once I have the main current, I can calculate the current flowing in this resistor and the current flowing in all these resistors, which I called ER6 prime. Once I have this current, I can calculate this current. And once I have this current, I can calculate the current flowing here in these four resistors. And again, using the current divider, I can calculate ER5 using IR3 prime. So let's explain what is the current divider rule. So we want to calculate I1 in function of I, the main current, and I2 in function of this current. So the current here flowing here is voltage divided by R1, and I2 is equal to V divided by R2, knowing that V, it's the equivalent resistance times main current. So the equivalent resistance is R1 times R2 over R1 plus R2, and we multiply it by I, and we replace V by this expression. We get the following expression, which we are going to use to calculate the currents. We can also use voltage divider rule to calculate all the currents. Well, I've chosen the current divider to calculate all the currents. So let's calculate first the main current and the equivalent resistance of this circuit. First of all, I see that we have R1 and R2 are in parallel, R2 and R5 are in parallel, later they are in series, and later they are in parallel with R6, R8 and R3 are in parallel, and then they are in series with this, and this is in parallel with R7. So we write the equivalent resistance. First of all, R1, this is first step, R1 and R4 are in parallel, first step. Second step, R2 and R5 are in parallel, second step. Third step, they are in series, this is the third step, these are in series, and later they are in parallel with R6, this is the fourth step. Fifth step, R8 is in parallel, R8 is in parallel with R3, this is the fifth step. Sixth step, they are in parallel, they are in series with this R4 prime, which I will call R4 prime, and later the whole is in parallel with R7, and this is our equivalent resistance. So let's write the values of these resistors. This is 3, R4 is 6, R2 is 4, R5 is 4, R6 is 12, R8 is 4, R3 is 12, R7 is 4. So let's calculate. Let's call this one R1 prime. This is R1 times R4 over R1 plus R4. That will give us 3 times 6 over 9. This is 2 ohms. R2 prime. This is R2 times R5 over R2 plus R5. This is 4 over 2. This is 2 ohms. R3 prime. This is R1 prime plus R2 prime. This is 2 plus 2 is 4 ohms. And R4 prime. This is R3 prime times R6 over R3 prime plus R6. This is 12 times 4 over 16. This gives us 3 ohms. And now we calculate R5 prime. So yes, this is R8 times R3 over R8 plus R3. This is 4 times 12 over 16. This is 3 ohms. And R6 prime is R4 prime plus R5 prime. This is 3 plus 3. This is 6 ohms. And our equivalent resistance is R7 prime. And this is R6 prime times R7 over R6 prime plus R7. This will give us 6 times 4 over 10. And this is 2.4 ohms. And from this we can calculate the main current. This is VAE over RE, and this is 24 over 2.4 ohms, and that will give us 10 amps. And from this we can calculate the currents. Let's take this board again, and we can use the current divider to calculate all the currents. Now we have the main current. We can calculate R6 prime that's flowing here. This is the whole resistance, equivalent resistance of this whole, the R in parallel with R7. So it means R6 prime is R7 divided by R7 plus R6 prime times the main current. So R6 prime is equal to R7, 4 plus 4 plus 6 times main current. This is 4 amps. Once we have R6 prime, we can calculate the current IR8. This is R3 over the sum of the two times this current we calculated. So it means R3 is 12 over 12 plus R8 plus 4 times 4, and this is 12 divided by 16 times 4. It is 3 amps we calculated. Now we need to calculate IR5. To calculate IR5, we need to calculate this current, IR3 prime. IR3 prime is R3 prime. We need these 4 resistors. So it's IR3 prime. This is R6 plus R3 prime times the current flowing here. So we need this current. So this current will be R6, which is R6 is equal to 12 over 12 plus R3 prime. R3 prime is 4 times 3 times 3. No, this is R6 prime. Sorry, this is 4. And it's 3 amps. Now to calculate this current, 3 amps, because it's 4 ohms here and 4 ohms here, I think the current will be divided in 2. I put here the expression for this current, but we can divide it by 2. It means that here we have half of this current will flow in our FET. Okay, I think that we finished. We calculate IR8, which is equal to 3 amps, and IR5 is equal to 1.5 amps. And thank you very much.